Well, welcome back to the SOL-20 restoration. In the last video we took it apart and checked the power supply. We found that this capacitor is kaput. We're going to replace it, and there's a couple capacitors, filter capacitors down on the board down here, and we're going to try to replace those. So I have the replacement capacitor for the big one. It's not even anywhere near the same size. It's quite a bit lower, but that will work. And then I have a couple for the main board. Hopefully we can get it out. And I did manage to find the transformer to do the transformer mod. Still made, so that's good news. The only other parts that were needed and specified was a thing called a commoning block. It's basically like a jumper bar, and it was going to go in here. That is hard to find. And then the crimp connectors that plug into it, I want to try to get that, and I did find some source for it. So it might take a while to get the pieces, but I was lucky enough to find the proper part and the proper crimps. We'll be able to see what it looks like when we start taking this power supply apart. Hopefully it's not too difficult. So let's get cracking. I guess the one thing I didn't explain was, you're wondering why we have to do this transformer modification when the voltages here were like 20 volts for the it was 11 volts for the +5, that unregulated 11 for the +5 cards, which is well within specifications of a 7805 voltage regulator. But some of these cards they have a lot of chips and they draw quite a bit of current. And so the higher the voltage has to drop, so say from 11 down to 5, that gets dissipated in heat, and if it's high current, it's going to be a lot more heat. So as we can see, that this board has like been heavily exposed to a lot of heat. So if we can bring the input voltage, because these chips I believe they work from 7 volts in up to 35 volts in, but if it's a low current, then it would be fine. But a high current, it has to dissipate it in heat when it drops from the 11 volts to the 5 volts, and that gets dissipated, and that's bad news right there. So the closer we can bring it down, so if we can get it around 8 volts with this high current, with this thing with all the chips, then hopefully we won't have this heat damage. So that's what we're going to do. We're going to try to do this. So this transformer, the way it gets mounted in here, and it's going to have 2 taps, and one will be 10% decrease in voltage and the other one will be 20. By the looks of things, it's going to be the 20% decrease that we're going to have to apply. So let's try and take this power supply out. You see there's some cut traces on the bottom here. And some components have been added on the top. So I'm going to say this power supply has been upgraded. Or the modifications, there's been a few modifications. Because this is an early power supply, early motherboard. And so some of the revisions have been applied to this unit. So when we take the motherboard out, flip it over and see if any of the revisions have been applied there. I wonder if this is marked on the capacitors. Plus. There's a plus on that side. Alright, so let's see if we can pop these puppies out. And there's a plus on that one too, so we can get these in the right way without screwing up. Let's give these a little test. Now we'll test them later. Let's put the new ones in and get this thing put back together. So, boys. I see 2 tantalum capacitors on there. Let's make sure we got this right. Negative, positive. One done. Positive line going that way. done. Alrighty, that is that. Might as well put this capacitor in. I have some little shims in here. I don't believe that bracket. See, this new capacitor is a little bit wider than the original, so I might not need as many shims in there. So where's the plus? Over there. Oh yeah, it's going to need some of these shims. Some of these in there. See if we can tighten this up. Good. All right. Negative side. Positive side. Go. All right. out, I'm going to install this transformer, because it does go in with these existing screws. And just then it will be in, but I won't be able to hook it up until I get the blocks. See what we do over here. So that way, this one this way. That one. It's not going to quite line up, but what we can do is pinch it off. Right here. Let's get it started. So then that will go underneath there. This one will go up into here. And this one will pinch off on that one. So we just need to wait for that connector and some of those crimp pins, which I might need to be, we might not even get power now that I bent that one and bent it back. It's not getting a proper connection. We'll find out. So that is that connected. So that's ready to be hooked up. Some of those connectors back there have to be redone anywho. Okay. I think we're ready to do a test. Alright, we're ready to give it a test. Let's plug it in. Turn it on. No smoke. It's a good sign. So let's start with the unregulated supply. Check the unregulated 8 volts. It's not going to be 8 volts. It's going to be more like 11. And we have, 10.7 with a ripple of 12 millivolts. Not like the last video, I was calling it milliamps. I don't know why I was saying that. It's written right on the screen, volts. So that's good. And we'll check. So when we do the 20% reduction, it should come around 8 volts. And these are 19.3 with 10 millivolts. And we have minus 19.7 what, 19 millivolts, 20. That didn't really change. But it's well within parameters. Now we'll go to the regulated supply. We'll check the plus and minus 12 first. So we got plus 12 with, wow, 8 millivolts. That's even lower. So changing those capacitors made a difference on the big board. Minus 12. Wow, that's good too. That's made a difference. So changing those capacitors on the main board, they made a difference big time. Now this is the big test. This is where we had all the problems. I believe it was 4.6 volts with like 600 millivolts of ripple. So we got 5.1 with 1 millivolt of ripple. Well, that's a huge difference. So that's very good. That's like 1 millivolt. That's like, can't get any better than that. So we'll check. Might as well check on this capacitor, which I believe was giving us like 6 volts and something, and 2.2 volts of ripple. And now we got 9.5 with 3 millivolts. So yeah, that capacitor was kaput, and now that is fixed. So the power supply seems to be doing really good. So we're going to end the video for today for there. We're going to pop this motherboard out in the next video, check the bottom, see if there's been any modifications. Then we'll apply power to it and go from there. So I need to get a screen set up, and that'll be it. We'll move on to the next phase. Okay, thanks for watching.